Okay, we're back for solving these functions. For each of the following functions f, find the following. So let's start with this one over here. So the domain and range. So for the domain and range, that would be x minus 2 has to be greater than 0. So x is greater than 2. That's the domain, and we'll write it appropriately with the curly brackets. And y, this can be any real number. Okay, we saw that before. It's always right. The y will always be any real number. Okay, find the asymptotes and x's intercepts. So in this case, the asymptote, the vertical asymptote, would be x equals 2. And in the horizontal, there is no asymptote in this case. Horizontal asymptote, none. X's intercept. So in this case, for getting the x-intercept, y equals 0. So that would be log base 5 of x minus 2 equal 0. So log base 5 of x minus 2 equals 2. X minus 2 equals 5 squared. X equals 27. That is the x-intercept. For y-intercept, x is 0. So in this case, that would be log in base 5 of minus 2 equal minus 2. So since this is a negative and it cannot be negative, it's undefined. So there is no y-intercept. Sketch the graph of the following. So let's sketch the graph. So it's looking like that. Okay, I know it's looking like that because it's log and the base is greater than 1. Now we need to show all important features. So that would be the vertical asymptote, which is x equals 2. And try not to touch the graph when you use a ruler. And this x-intercept would be x27. Great. Solve f of x equals -1 algebraically and check the solution on your graph. So what we need to do is just log of base 5 of x minus 2 equals -1 in this case. This is like y equals -1. So log base 5 of x minus 2 equals 1. Then x minus 2 equals 5. X equals 7. This is 5 to the power of 1. Yeah? So x equals 7. So if we're using, we can use a graphic calculator and see that we get this result here, which will give us 7 and -1. If we're using a graphic calculator, then we're graphing this graph, this one, and the graph of y equals -1 and looking for the intersection point. Now find the inverse function, f of -1, then f of x would be y equals log base 5 of x minus 2 minus 2. So for the inverse function, we change between the x and the y. And we isolate the y. So this is our inverse function. Nice. Okay, so the key points here, the domain, okay. It's easier for me to graph it and to understand, but the domain and range, the domain would be that this part of the logarithm has to be positive. The range is usually, most of the time, if not always, then the y belongs to all real numbers. Find any asymptotes and x's intercept. So that would be in the vertical asymptote. There is no horizontal asymptote. And the x's intercept is when you need to substitute y equals 0 for the x-intercept and x equals 0 for the y-intercept. Sketching the graph and showing all important features. So this would be the graph of the logarithmic function, where we state the vertical asymptote and the x-intercept. Solving algebraically, this would be an equation now, a logarithmic equation. And finding the inverse, we switch between the x of the y of the function, and then we isolate the y. So those are the key things that we'll see again and again in all different functions for finding the inverse functions as well. And reminding you the reflection on over the y equals x. This would be for ln, okay? And state the transformation which maps ln of x to f of x. So we see here the transformation would be on the x-axis is 1, and on the y, that's for the y, that would be the vector of translation. State the domain and range. So x minus 1 greater than 0, x greater than 1, and y belongs to all the real numbers. Any asymptotes? So vertical asymptote, and write the whole name, okay, in the exam. X equals 1, x equals 1. Horizontal asymptote, there is none. Intercepts, so let's replace that for the y-intercept. X equals 0, we get ln of minus 1 plus 2, that means undefined. X-intercept, y equals 0, we need to solve that. Ln of x minus 1 plus 2 equals 0. Ln of x minus 1 equals minus 2. Then x minus 1 equals e to the power of minus 2. Ln reminding you that it is log with the base e. So in this case, x equals 1 plus e of minus 2. That's the x-intercept. Sketch the domain. We see it again. So we have, what is the asymptote? We see it's over x equals 1. And this would be 1 plus e over e to the power of minus 2. And it will look like that. Find the inverse. So finding the inverse would be for the function y equals ln x minus 1 plus 2. For the inverse, x equals ln y minus 1 plus 2. And then we need to isolate the y. X minus 2, y minus 1 equal x to the power, y equals e to the power of x minus 2 plus 1. Let's see, let's go back and see maybe a bit more of the transformations here. So this would be a shift. If this is log in base 3 of x, log in base 3 of x plus 1 would be here. A shift, translation to the left by 1. Here it's log that we see if this is log base 2 of x, this would be a vertical translation downwards. And here we see, because it's this, I can write it as a minus log base 3 of x plus 1 plus 1. So if this is, first I'll draw log in base 3 of x will look like that. Then that would be a vertical translation upwards. That would be a horizontal translation to the left because it's a plus 1. It's the counterintuitive. And the minus before the function will be actually a reflection on the x-axis. So this would be our solution at the end. Okay, so I'm stop here and then we'll go to part 3 of this presentation.